In that episode, we finally want to make our XLeRobot to do something useful, to collect the trashes in your room or bring you documents in the office. My name is Grigory, and in that final, probably, episode of the XLeRobot series we're going to solve so-called generalization problem, allowing the robot to operate by itself and make own decisions on how to perform given task. This is the biggest problem in the robotics right now. Which practical tips about improving your VLA training we learned, I'll share in the video. Why reducing the amount of training data actually help to improve the VLA training, and why, in my opinion, the most of the robotic community is completely wrong about how the biggest problem, generalization, should be solved. Welcome! In previous episodes of series, we placed an LLM agent inside of the XLeRobot to make robot drive autonomously, make own decisions, and listen to voice commands. Later we added VLA policies as a tools to make LLM agent be able to manipulate objects with robot arms. Theoretically, what we have now should be completely enough to make robot to do some concrete, useful tasks in your home, like bringing small objects. But truth is that both arm manipulation and navigation work just bad and do not work together at all. VLA models we train to grab a notebook actually grabbing it very rarely, often missing it. You can see that for some strange reason, VLA very often tries to grab notebook somewhere above or nearby it. When after dozens of tries it finally grabs a notebook, grabs it accidentally. Our guess is that our models have some problem with understanding video input. For some reason they play exactly the same animation of grabbing all the time, independently where and if notebook lies. Maybe our arm will be finally able to grab a notebook if we power it with some more advanced model. Okay, so now it's time to test the Pi 0.5 policy, and our robot tries to grab the notebook using it.
Loading.
Pi 0.5 works exactly same bad as previous models. Seems problem not lies in the model computation, but where? The suspicion we have are settings of the VLA inference. Every VLA model has few parameters to set, as for example FPS, or how many times per second our action should be executed, or action horizon, how many future actions our model generates at once. What if the problem just caused by the bad tuning of the settings? That's how our robot works in 15 FPS. We reduce 2 times the amount of FPS, and you can see it becomes to work much more smoother. But despite of small improvements in inference quality, parameter tuning doesn't solve a main challenge. ARM still misses notebook in most of tries. But even if by some miracle we will be able to grab our notebook properly, what is the point if we will not able to maneuver to it? It either tries to grab notebook too early, or too much from the side, or just can't align with it. Our navigation is very imprecise. If we really want our robot to work autonomously, we need to solve both navigation and manipulation problems. We try to improve the prompt of our agent to make our robot to operate well, because his navigation ability are not so perfect, and we describing him how to exactly behave in different situations, when he, for example, close to his target or far away from it, and to move shorter or longer moves, to activate precision mode or use that normal fast mode. Good prompt is important thing, but no matter how much we improve in the prompt, robot still constantly collides with obstacles when navigate close to them. Yeah. Now we're working on different tools to improve the precision of movement of our robot to make him move more precise. So one of the things we introduced is the precision mode. It's the idea of our contributor Neo, our big greetings. The problem is our camera looks forward. It can see obstacles that placed few meters away, but cannot see obstacles that placed very close to the robot. When robots decide to go into the precision mode, it rotates camera down, so it can see own body and objects around it to make little, precise moves to fit every surroundings. That improve robot navigation, but not entirely. Robot body is very wide, so when our notebook places a little bit sideways, our robot cannot turn to the direction of it, because his body edges will hit a table. To solve the problem, we added the strap right and strap left tools, allowing robot to move sideways without turning. It works like this. No, it should work like this. Because of our improvements, robot navigation abilities became better. Still, often became undecisive because of too restrictive prompt, sometimes still goes into the wrong direction or cannot grab a notebook because of badly working VLA policies. However, the improvement is clearly visible. But we did enough to do a full office task of grabbing the documents and bringing it to a human. Tries to grab, but too early. Robot is too far from it. Comes closer and repeats, and on third try it grabs it.
Okay, he finished his manipulation tool and now he should go to the human. He found me and goes to me. He goes to me and wants to give me a notebook.
Tries to grab a notebook. He can't. It's thrown too deep into his basket. Conrad helps him a little bit, replacing a notebook at the good angle. The robot grabs it and tries to give it to me. Perfect. Oh, you see that? Beautiful. We just accomplished one full office task of bringing a document to the human. The biggest problem in the robotics right now is the generalization. Making a robot be able to completely autonomously think, orient in the environment it never been trained for, and do its task, like bringing documents in the office. Most of the robotic community, however, thinks that to achieve generalization we just need to create better VLA models, teach us with better data, invent some better ways of training it, and so on and so. In my opinion, it's complete nonsense. VLA models itself can control robot arm to grab a notebook from the table, sometimes even successfully. Yay! But they cannot reason, think few steps forward and plan complicated missions. In my opinion, to really achieve the generalization, we need something that thinks to be core of our architecture, so-called System 2, and LLM is the best fit. LLM which analyzes the environment, plans and makes thoughtful decisions, and executes it using VLAs or other tools. Okay, our next target will be even more ambitious. We want to make robot to be able to clean up the table in your room. His task will be to collect all the trashes from the table and bring it to the trash bin. For that we equip the robot with additional accessory, the mobile trash bin with changeable bags.
Okay, we need to move our robot base to the front to make the range of our arms just bigger, because now when our robot base is on the back, our arms just cannot grab all the trashes. Some of them are just too far, but when we move the base forward, the length of the arm will increase.
After some practice, we are able to collect trashes with teleportation really fast, which is later turns out to be our big mistake. But for now, we are training a model based on the collected data, which is obviously not going to work since our models does not understand a video input.
Been thinking about why our arm is very rarely able to grab the notebook. As you see, video is merged badly because at the beginning of the video we have like rest of the previous episodes, and the new episode, the current episode, starts in just somewhere in the middle. Our robot is not able to train from video, that videos are just random, and it only trains from the arm position to do some animation all the time, independent what camera sees.
Luckily, after next LLM library update, the problem gone. So now our dataset should work properly. Before we assign our trained model to the agent, let's test it, and when it works. At least we thought it works.
Wow, fast and furious.
After first trash is collected, the robot hit the table in the exactly same place again and again, trying to collect already collected trash. In meanwhile, we got to the LLM Warsaw Hackathon, where we learned a lot of techniques about how to train VLA better, which I will share with you in a while. During the hackathon, we managed to teach a robot to do a tea with sugar using the techniques. But for now, what's going on the navigation abilities of the robot? It's not bad already, but not perfect enough to align with our trash precisely every time. The single way our robot understands its environment is his top camera, which does not provide robot with precise distances to nearby objects, introduces occlusion, and cannot see robot's surroundings. But what can we do with it?
We have bought few new toys. This is 2D LiDAR sensor. We'll see if it will help the robot to navigate better. It's quite big, actually. Let's test if our LiDAR sees anything. He's doing something anyway. Okay, we can see that he actually measuring the distance. That rectangle is the robot from the top view, and that red lines is the walls our LiDAR sees.
Using LiDAR, our robot finally starts navigate good, able to approach table with trash precisely. It can see the robot surroundings from the top-down view, including camera dead areas. Okay, but what about the arms? Let's make them work also. Without proper trash collection, our robot will be useless in the most of the whole tasks.
Our new approach to collecting the trash from the table, after we learned a lot of new things during the hackathon, we know how to record the episodes better, we learned a lot of new techniques and implementing them now. For example, to make the move of the arm more slow, the way we record in our datasets make huge difference. We approach it slowly and throw in here.
It's very important to not hurry when you record your UV at a dataset. Exactly what we did during previous recordings. Do it slowly. The model have enough frames to learn how to perform all such or another situation. Another lesson we learned: avoid useless moves. Just go straight to the target to avoid garbage data in your dataset. Lesson third: keep gripper close to surface using our special Cobra move. That way, the object is never covered from the top camera by the arm, and there is just bigger chance to grab your object, even accidentally. But will all the changes be enough to finally make our arm grab a trash? Using that techniques, we recorded the throw out trash dataset also. Okay, so for now I tried also to run more advanced models like Pi 0.5 or XVLA, unfortunately with no success. Unfortunately, only the old ACT and small VLA models are maybe not the best, but single models which are able to reliably run for client-server architecture. We decided to collect only single trash at once to make job of the model easier. And it actually works. Very often in our experiments, the arm during the VLA inferentiation goes just too high over that leaflet. A very strange behavior, but finally we came with idea. The reason was the different calibrations of the arm. In the laptop we recorded our dataset, and the Raspberry Pi we interfered. So you can now talk with the robot through the headphones.
Yeah.
robot customer support.
Previously, we thought that the bigger dataset we have, the better. We collected a dataset of 1 or 200 episodes. But at some point, we realized that datasets of 30 or 40 episodes perform just better for some reason. And they are obviously easier and faster to collect. Let me know if you want me to investigate why it's happened more deeply in the future videos. For now, we have arm manipulation improved. But will it altogether be able to clean up our room? It's time to make a final test. As always, all the code improvements we did, we open sourced within the RoboCrew library. First link in the description. You can already today test our code on your robot, for which I encourage you. If something will not work in our code, let us know by raising an issue. If everything will work for you, let us know as well. After all, we write the code for you, so it's very important for us to hear your feedback. And today, I'll appreciate if you not only leave a like under the video, but also leave a star on the RoboCrew GitHub to support the project.
It's final day of our sprint. I need to make my robot work. Now, on it.
We have 2 tissues on the table to collect. After robot did it, we need to take the tissues to the trash bin. Okay, first try.
Grab it. Very good, very good, very good, very good, very good. Very good. Amazing. It did at least 1 tissue for now. Okay, try to grab second tissue. Almost, open it, open your mouth. Yes! Yes, it did it. It did it very good. It's constantly targeting on the bin, but since it's closed from one side by chair, so that's why it's maneuvering the strange way. Okay, robot decided to go back to chair, to table, to collect tissues. I don't know what he's doing. Why he not going to the bins back? Or maybe close the bins? So the problem I see now is that our robot, after collected all the tissues, after some time forgotten that he tries to go to the bin and returning back to table to collect some tissues when it's no tissues anymore. We need to improve somehow his memory. I'm very angry already, but because it still not work, and we have just few hours till the end of the day.
Once again, robot reaches a table, tries to collect a tissue. Yes, tissue is in the bin. Another one. Oh no, he misses! And misses again! One more try. Yes, tissue collected. Table is clear. Robot looks for a bin and goes to it. Bin is approached. All the robot needs to do now is to throw out the trash to finish the task. And at that moment, robot arm stops working.
Okay, so it seems something wrong happened with our robot. Arm program-wise arm is disconnected, so something get wrong with policy inference. We need to debug it.
When I restarted an arm, I realized it's not able to grab a trash bag properly. It constantly tries to grab on the side of the handle.
So to improve the issue with that robot grabbing bag just in that wrong place, I will review the dataset we collected and will remove episodes where we grabbing it just on the edge and leave only the episodes when it grabs the bag. Not there, but somewhere there. Now our new dataset have only 30 episodes instead of more than 50 previously. And on the base of the dataset we train a new model now, new small VLA, and we'll test how it will perform after a while. It's time to eat, I'm very hungry actually.
But will the improved model work a whole run will finish again with no result. Robot again starts its hunt for a trashes. Miss. Another miss. Teacher grabbed and placed to the bin. Second issue is in the bin as well. Robot looks around for big bins and goes to it. This is the final stage of the run. If robot will miss a bin and throw the bug just nearby, all progress will be lost. So only one bug to throw out. Moment of tension and... Yes, bug is on the bin.
Yes! Yes!
Robot did it.
Finally that moment happened. Robot did all the cycle and I'm so happy about the fact.
To ensure our success is repeatable, we need to test it one more time. If robot failed this time, it will mean that previous success been achieved just occasionally. And this time, robot did its run much faster. It took him not a half an hour like previously, but only 15 minutes to clean up the table. In that video, we finally managed the robot to make a concrete, useful tasks like cleaning a room or bringing a documents by itself. That means successful end of the XLeRobot series. Or at least first season of it. And if you may be interested to go deeper into the VLA training, I have prepared a few tutorials about it for you. Bye!